Welcome to what it says on the screen, physics, material and friction. In this video we are going to talk about physics, material and friction. Sorry to be trite. So the point is the tank's going to be to move because we will have assigned physics materials to the tracks and we will have adjusted the frictional values and the driving forces so that our tank can move in a slightly strange way from the moment, but at least it's moving. So we've been applying a force to the tank. We determined by having the tank float in the air that it should be sufficient force to make this guy accelerate, but he's stuck to the ground. What are we going to do about that? There is a certain amount of friction between the tank and the ground. As you can see, when we get hit by a projectile, we slide for quite a long way, but we do come to a halt. So let's now tweak two things: the power, or the force rather, that we are pushing the tank with, and the friction between the tank and the ground. Let me show you how to adjust both of those things. So if we go to the tank blueprint, just to remind ourselves how it's put together and to take a look, good place to orientate ourselves. It's these tracks that are in contact. Well, it looks like it's the tracks that are in contact with the ground, but actually right now it's not, is it? If we go to the battleground, play the game, depossess with F8, and make sure that collision is on under the show menu, you'll see that actually we've just put, it's very, very hard to see this, it's a very thin purple box, but we've just put a, I got hit. We've just put a single box collider on the tank. So there's this big slab we're trying to move around. And when we get to hills and things, that's not going to respond very well. So we are going to now move back to having discrete components. And if we have any problems with self-collision, then we will overcome them now rather than working around them. Last time we worked around them because it was good enough to get moving. This time we need to confront the issues head on. So one thing I want to say before we do that is I am on Unreal 4.12.4. If you're on an earlier version of Unreal and that, please upgrade to 4.12.4 because we were experiencing problems in any previous versions, particularly in 4.12.3, with the way that components with colliders on them interact with each other, something to do with welding. Okay, so let's go ahead and change the way these colliders work. There's our tank body. Remember that it has a primitive on it, which is just a box right now. Okay, so what we're going to do is just show collisions. I'm going to take a left view, I think will be from the front, strangely, because of the way our tank is orientated. And I'm going to change the Y extents to bring it in, a little bit of clearance between the body, collider and the tracks. Change the Z extents a bit, and then move it up in the Z position. Like so. So now we have a collider which mainly covers the body of the tank. Great, let's look at that in 3D. You can see that it's covering mainly the body. Now that paves the way for us to actually put collision back on the track. So let's go ahead and do that. We can go to the tracks, we can go and find the track mesh, which is here. Where is it? It didn't come up. Let's go find it. There we go. Track mesh, turn on collision. And you can create yourself a 26 DOP collision mesh, something like that, which looks about right. It's going to behave quite well going up and down slopes without being overly complicated. And now, when we go back, let's go ahead and just play the game and see how we get on with that, with those two separate collision meshes. Now, if you find that your tank, one of your tracks falls into the ground or something like that, please check you're on Unreal 4.12.4. Also check that this works from the main menu. This is a great time to be checking that, because what we've noticed is a problem with the way that the tank is constructed in terms of a timing problem. It's what we call a race condition. And the place that this may manifest if you're having a bug is as follows. What you have is the tank, and then you have the left and right tracks as sub-objects, and you'll notice that you should have a property ticked on those called auto weld. If I can find it. Here you go. It's under physics, and then the extended physics properties, you need to do the drop down under physics of the left and right track. Under the extended properties, you have auto weld. If you were to turn auto weld off, let's see what happens. You see it ignores those track colliders. It's just landing on the body collider. So we do need auto weld on because we want the collision meshes of the tracks to weld into the same mesh as the body, as it says here. If true and is attached to a parent, the two bodies will be joined into a single rigid body. Physics settings like collision profile and body settings are determined by the root. So they're saying that the root up here, the tank, will determine the mass and all the other physics settings, but these left and right tracks will contribute to the overall collision. Okay, so you do want auto weld on. Now, it's possible that you can get a problem where auto welding doesn't work, say, from the main menu, but does work from the game. And this could be to do with the time that the objects are constructed and whether the welding works properly or not at that time. If you're having that trouble, then there is a way to get around it in Blueprint, but I don't think you'll be getting the trouble in Unreal 4.12.4. I haven't seen it once in this version. So if you're really stuck for any reason or you're getting any horrible behavior here, then remember you can always go to GitHub and you can go and get our project at this stage by following through to Unreal, then the section, then the commits, find the video, this video, which isn't there yet, and then go and get the code by clicking on it or by clicking over here on the right, and you can clone or download the repo. Okay, so that's important. All right, so I think we've said enough about that. We have now got the tank resting on its tracks. So why isn't it moving? Well, firstly, let's get control over the friction between the tracks and the ground. If we go ahead and look at these tracks and scroll down inside the tank blueprint, you'll see you've got this physics material override option under collision section. Well, there is no material. So let's make ourselves our first physics material. I'm going to put that in the tank folder because it's very much related to the tank. And then I am going to go to Add New, scroll down to Physics, and it's actually the only thing in it, Physics Material. I'm going to call it Track Material, or just Track, because it is of type Physics Material, so we don't need any more naming than that. And if we go into it, we can see we've got a few basic settings. One of them is friction. Let's turn the track friction down to, say, 0.2. Now, there is an issue of friction combine mode, and this is set in two places. This is answering the question, how do I combine the friction setting on the track with the friction setting on the ground? Now, where is that friction setting on the ground? Well, it's in the actual grass layer info here. Whatever you've painted the ground with at that point, whether it's grass, mud, ice, whatever, in that layer info, you can see that there is a physics material option. Now, the grass doesn't have a physics material at the moment. We could give it one, but that's beyond what we need to be doing here. We could assign different physics materials to grass, snow, ice, and have the tank behave differently. But for now, let's keep it simple. So we won't do that. But I just want to point out that the friction is not just determined by the track's friction, but it's combined with the friction of the ground. There is also a project level setting under Project Settings and Physics, which determines in general, or by default, how these things are combined. And it's here, friction combine mode. I'm not going to change that. I just want to give you the context. The way that we're going to make our friction work is quite simple. We're going to override the friction combine mode and choose minimum. And that means that we are going to most likely, given that the other thing that we're touching, the ground doesn't even have a physics material, we're most likely going to end up with this 0.2 as the minimum of the two physics values. Okay, so let's see how much difference that makes. We need to assign this physics material to both the left and the right tracks. Now that we have it, we can just go to collision in the tank blueprint, select the left and the right track with the control button, and then for physics material override set track. Remember to compile, and now let's just try moving the tank. It's not quite moving. See that other tank though? It slid down the slope a lot faster, so there is a lot less friction on it. And that looks fairly reasonable to me. So the next thing to do is to increase the force with which we move the tank. Now, this isn't an ideal way to move this tank. We're moving this tank by shoving it along the ground on these flat colliders. There are other ways that you could approach this. You could, for example, put some hidden wheels, a bit like these actual wheels underneath the track. And you could use things called physics constraints, which are down here in the physics section. And you could try and make axles and make some wheels move, but you'll end up with your own problems doing that, with different types of problems. And you could try and have wheels that revolve and pull the tank along. But the way that I'm going to show you how to do this, by just making the tank pretty slippery and then using some code to stop it sliding sideways and looking like it's on ice, is going to be more general. It'll allow you to make hover tanks. It'll allow you to do basic things with certain types of aircraft or air hockey. And you're going to learn more by doing it this way. So let's pursue this route. All right, so these tracks have got this track material on them now. As I say, the only thing that's making it not be able to move is that we haven't got enough driving force. So I'm going to turn my driving force up. In my case, it's now at 4 million. Let's try that and see if it's enough. I'm going to pull both throttles to 100%, and it's not enough. So iterate up again to 40 million. Now we're 1,000 times bigger force than we expected to be now. But that's because of the amount of friction. There's a huge difference between pushing a frictionless tank and expecting a tank with 40 tons of force to slide on massive tracks. It would take a huge amount of force. And there you go, it's moving around. In fact, I'm going to turn my game controller on and just have a quick go from the game controller before I put you into your challenge, which is just going to be to tune up your physics, your combination of friction and track friction and driving force. Cool, that's fun. Okay, one final thing before we do that. Let's go to the project settings, input, and I'm going to bind the shoulder buttons for a reversing throttle on the left and right. I'm going to get rid of these left and right keys, I think. And instead of that, I'm going to look for shoulder button. Left shoulder gives me an input scale of, say, minus 0.5, driving back at half speed. It's like pulling the trigger in halfway. And the right shoulder will give me minus 0.5 as well. Bear in mind, if you ever exposed this as a sensitivity to a user, which you probably wouldn't do in this case, you might with the triggers, but you probably wouldn't with the shoulder buttons, then they could, if you allowed the user to change this 0.5, they could potentially make their tank go faster than somebody else's. So beware of that. But for now, it's absolutely fine. Worry about that if and when we ever expose that value. Now, this is me holding both shoulder buttons on my gamepad down. And if I hold down both triggers, then I can go forward. If I hold down just the right trigger, or just the left trigger, now it's sliding all over the place, but we'll sort that out later. And if I hold down one trigger and one shoulder button, I can rotate. So look, we have agency. We can move the tank and we can aim the tank. So we are starting to get there. I think I've got too much friction, or too little friction rather, but it's difficult to say because shortly we're going to stop these projectiles from actually making us fly like this because they don't need to be doing that. We can handle the projectile collisions rather than with physics as actual just events and then decide how to process those events. So I'd like you to tweak your physics settings. Set your track max driving force. I'm using 40 million newtons in my case. What is 40 million newtons, by the way? Well, a kilogram weighs about 10 newtons, 9.8 something. Depends where you are on the Earth. Call it 10. So 40 million newtons is 4 million kilograms, which is 4,000 tons. So that's a lot of force. But with a 40-ton tank sitting flat on the ground, it's possible that it needs that much force to move. So it's still within the realms of possibility. The problem is that we don't have revolving wheels, and the reason is that it's quite hard to model a tank. They're quite a unique way of moving. They're neither wheels nor are they slabs. That's the thing about tracks. They're wheels. They're kind of moving slabs with wheels on the inside.
Just a quick post edit by Sam here, just to point out that we're using actually 400,000 newtons, not 40 million newtons in this case. The reason for that was that Ben was talking about, or assuming that the unit of measure in Unreal was meters, and in fact it is centimeters, so it's 100 times less. Thank you to Mert on the Q&A for pointing that one out.
So, set your track physics material, friction value. I'm using 0.2 for this. And by the way, a friction coefficient of 0.2, you might wonder what it means. I hate things without units, right? Well, actually, the friction coefficient of 0.2 is unitless, which is why I've not put a unit there. But what it is it's a force, just like a contact force, and it's 0.4 times the contact force. So however hard the track is pushing into the ground, typically on flat ground, that would be half the weight of the tank. However hard that track is pushing into the ground, what this friction force means is that the tank will start to slip when you push it sideways, forward, backwards, left, right, with 20% of that contact force, okay, on that track. That's what a friction coefficient means. It's a proportion of the contact force at which point you start to slip. So go ahead, pause the video, tweak up your physics settings now, and when you unpause the video, it'll be the end of the video. So just tweak your physics settings, and why not share what you've done with your physics settings over in our new community. You're probably aware that I've made community.gamedev.tv here for you. There's a lounge that anybody can join. There is, more importantly, Unreal, and you can go straight to the battle tank section and you can go ahead and discuss in there, and you're going to find all sorts of interesting things. Please do check out this here, the hover tank project. One of our students has made a fantastic looking hover tank. Look at this for inspiration. Low poly, eerie landscape, some nice effects on it. So do share your work in there, and I will see you in the next video.